Hello everyone and welcome back. Hope you guys are excited. As you know I am. This game is actually really fun. So we've got last time we've got our characters done. They're all in. We have our backdrops. We coded the basic stuff to swap through everything. So today we're going to be focusing in on applying the concepts of gravity. So if you guys watched last week's video on gravity, you should know that gravity is like a constant force that sucks things together. In a game, we don't have to really emulate everything about gravity. We just want to emulate like the properties of gravity. And in our scenario here, we have a really large object that you can envision as like the Earth or something like that below us, and a main character. We need to simulate our main character falling down constantly to this area down here. To do that, it's fairly simple. Gravity is just a constant downward force. So all we have to do is when our game starts, this is going to be a separate line of thinking, by the way. When our game starts, constantly, and when I mean constantly, I mean like forever. Forever, we are going to take our current momentum, which is how quickly we are currently going, momentum by our gravity value. To do that, we can actually just grab this guy, and he should just fit in right here. Change momentum by gravity. Watch this. If I was to start this up, oh wait, it won't do it quite yet actually. So this is going to change our physical part right here. Now, all we have to do is wait for it to send us downwards. To do that, we have to physically reflect our change in momentum over here with motion. Change y by. And this is going to be changing our y by our current momentum. There we go. This should do it. When I click on it and go over here, you should see our character just start falling in a fairly rapid pace. Like that. See how quickly gravity takes hold? You can see it's also fairly, there's like a curve to it as well. So instead of just falling neatly down at a steady pace, he starts pretty slow and then he accelerates. Just like how gravity works in real life. When you drop a ball, it's not going to fall at instantaneous speed. It's going to take a moment to start gathering momentum as it falls down. So we've got this part. Fairly simple so far. The next half of this is to make our character be able to jump back up. That's easily done as well using the event that we actually sort of hinted at on our main screen here. Take a look. Space key to jump. In our code for our character here, we're going to have to create an event that will trigger whenever we press on the space key. There's multiple ways to go about this, but the easiest way to do it is just to have when space key is pressed. I think you guys have seen that quite often already though, so I want to show you guys a new trick. Shoop. Throw them over here. So we already have this going on constantly when the game is started. What we can do here, to instead to prevent any sort of weirdness, like our character going, spazzing up and down constantly, but when we hold the space key, in here we actually have an alternative way of checking to see if a certain key is pressed. You guys might have seen it before, but if you head on over to sensing, there's a specific option called key space pressed. It's very similar to the event over here, actually, but instead of taking it directly from the keyboard per se, it's actually just checking to see if the space key is currently pressed, without any of the weirdness that your keyboard could have with repeating keys. Sounds a little complicated, but the main idea here is this will be smoother, regardless of your keyboard settings. I'm going to throw this in somewhere in here. We're going to need an if statement, though. If our space key is being pressed, we've already changed our momentum. This is going to be a constant thing. What we should do then is check to see if our momentum, or if our space key is pressed, we should actually add our power to our current momentum. Just in line, before it actually affects our Y at all. So that way it'll prevent any weirdness from happening. We're going to change momentum by our power. With this, we actually have everything we need to make our character move smoothly up and down. See? You might notice though, hey, we're going pretty fast up and down. I've held down my space key here and I've actually released it. I've held that up and now I've released. Watch how long it takes me to fall down. That's because our momentum is not capped right now. If I actually turn on our active momentum check, see here? Instead of being -20, we're falling down at a very rapid pace. Now I'm holding down my space key. This is why we have the caps. So we're going to add a little bit more complexity here to this part of the script. We only want to change our momentum down by gravity if we haven't hit the maximum velocity yet. I'm going to stop this for now. We're going to have to use a series of if statements to check that. In our control section here, we only want to change our momentum by gravity if our momentum is less than our maximum, right? Or more like less than or greater than our minimum. That's the correct way to say this. So our minimum, if you remember, has to only be -20. So what we're going to do is we're only going to add this value here, this gravity, if our momentum is not greater than 18. Now you might be wondering why 18. The reason for that is because we do want our momentum to go to -20 as our maximum, and not necessarily to 20. Because if we did that, our effective minimum would be -22. So we're going to need to grab these comparisons right here. Here we have our minimum momentum. It's going to be -20. So I can actually just plop this in right here. If our momentum is greater than minimum momentum, then we're going to change our gravity, change our momentum by gravity. If I just did it like this, if it was 19, for example, 19 or negative 19 is greater than negative 20, this could send us down to negative 21. So we're going to have to add 1 to our momentum to make sure that we don't go beyond it. We can check this now. If I actually plug this back in now and watch the live readout, we shouldn't go beyond negative 20. Nope. I see we're going to minus 22. That shouldn't be possible. Let's take a second look at this. And I'm back. Here we actually have to go in the opposite direction. We have to subtract 1 to make sure that we never go beyond negative 20. See, now it's more easily recoverable in either direction. I never get to the point where I cannot hold down the space key to go back up very quickly. And I'm gonna try again. Okay. Just a second. And we're back. Alright, so now we have our momentum capped in the negative direction. We have to actually cap it in the positive direction now as well. We're going to be using something called Boolean operators. Boolean operators allows us to combine multiple conditional statements into one statement. It's like having multiple requirements that you have to pass before you're allowed to do something. So imagine this. You're at home, you want to play your video games, but your mom says, hey, you need to go outside and do the dishes, take out the trash, and walk the dog. Those are 3 conditions that you need to pass. And you have to do all 3 to do it. The combining of all these is an AND statement. You have to complete A, which is the taking out the trash, B, which is washing the dishes, and C, which is walking the dog. If all 3 have been done is the only time when you're allowed to play your video games. This is what this AND sort of reflects. You need to be holding down your space key, and you need to be doing something else here as well before you can change your momentum. We're going to need a similar property like we did before. We can't let our maximum momentum go to an extreme situation. So right now I could click over here. I've already removed my space key so you can't see it. But if my momentum was to go beyond 20, I could be stuck up there forever, as you guys saw before. So we need a condition that prevents us from going way, 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 way up there. That can be resolved with this guy right here. This less than 50. Of course, we don't want to keep 15 here. What we want to see is our momentum is less than our maximum possible momentum. And again, just like before, we do not want to go beyond the actual cap. So we want to add 5. Or at least I think we need to add 5. We're going to try that out. If our momentum plus 5 is less than maximum momentum, then we can add our actual power. To make this more flexible, we should actually set this up so that way it's based off of our actual variables. If our momentum plus power is less than our maximum, that means there's enough space for us to add our power to that momentum and still be within our grounds to do so. Let's try it out. See? Doing pretty good. Cannot go above 20. Perfect. Now, you guys might want to take a moment to actually adjust these variables if you want to have more control over your character. If you're looking right now, you can see that my character goes way up and way down very quickly. If you want to adjust that, you are going to want to adjust your gravity. Let's say I want to make him fall slower, I can do -1. And if I want to make him ascend slower, I could do 3 as an example. Now if I go in here and I run it again, it's a lot more stable now. It can still go really, really high, but again, I can adjust this by changing my caps. So if I wanted to make it so that way my maximum fall speed is slightly slower, I can set this to -10, and I can set this to +10 as an example. Then I have a lot more control. I cannot go above a certain amount. I cannot fall beyond a certain amount each time. By setting up the math like I did here with these variables, we do not have to change all of our code over here. We just need to change these guys in order to affect how our game plays over here. With that, we've got our main character going up and going down. The only thing that we really need now is more of like flavor stuff. Well, there is one mechanical thing that we need to do, and that is checking to see when we lose. This part right here is just going to be our constant actual like motion loop here, but we are going to need an actual checking loop here to see when we actually hit an item. Specifically, if we hit an obstacle. To do so, we're just going to be constantly checking to see if... Actually, there's a unique way we can do this too. So I'm going to throw this over here and show you guys a new way. There's a specific looping style block that I haven't really shown off much yet, which is repeat until blank. What this is a constant check to see if something is, if something has been done. And if that thing hasn't been done yet, we keep going. We're stuck in this loop. It literally means repeat this action until this value in here becomes true. Essentially, we're going to want to repeat our check to see if we are currently hitting any obstacles forever, essentially. We're going to repeat at this doing nothing section until we hit something. And when we do eventually break out of this loop, we are going to broadcast game over. Just like so. If you guys want to simplify this, and if you have sharp eyes, you could already possibly have seen that, hey, we could actually simplify this down a bit. Which you can if you want to. I'm going to keep it like this for now, but if you want to reduce the complexity, you can move actually everything in here to be in here. Actually, let's just go for it. It's better to have simpler looking code in the long scheme of things. So I'm just going to take this guy and throw him back over here. Repeat until we hit the obstacles. Change our momentum. Broadcast game over when we do hit something. Fairly simple. And you should see it should still work. Just like before. One thing that you might want to add too is the ability for your character to tilt a little bit with your momentum. So if you guys are watching right now, my character is just floating up and down, and it doesn't look very realistic at all. It's just like, it looks like he's being pulled along by a string, if I'm completely honest. What we want to do here instead, if you like to, this is an optional part, you can add some ability to tilt up and down using the rotation. So the best way to do this is look at your current rotation. In the momentum block, or in the motion section, there is a block that can change our direction. Point in direction 90. So it's currently facing 90, and I want to tilt back a little bit if it's going up, and down a little bit if it's going down. This is easily done by just taking this 90 and using a little bit of math to change the actual location of where it's going. 90 plus our momentum. This is completely optional, but if you do something like this, you should see our character doing something a little bit weird here. It's going in the wrong direction, it looks like, but it's close. We're going to have to invert that, which is easily done by taking this guy and swapping him out with the negative variant. Now the reason why that happened is because direction doesn't necessarily move in the way you think it does. To go up, you actually need to subtract. To go down, you need to add. Very weird, I know. So you're thinking, why would you subtract momentum if you want to go down? Well, if you recall, our momentum for going down, this number is going to be negative. A number minus a negative number is going to be the same as adding the positive variant of that number. So you can think of it, if my momentum is negative, it's the same as 90 plus my momentum. If my number is positive, it's going to be 90 minus momentum. Let's start this up. There we go. Very smooth. And that's the character, guys. The next thing that we're going to focus on is the actual object cloning. So, our obstacles have been ignored up until now, but that's because there's a couple of things that we're going to be doing here. And that's going to be involving a whole new set of blocks that we haven't talked about yet called cloning. So, what is cloning, you might ask? Cloning is the idea that you have a single sprite, which is the template for an object that you want to create. This template can be recreated over multiple times in order to create multiple objects, multiple instances of the same object that can be interacted with. Think like this. In Mario, there's multiple coins that you want to collect. It's not like the programmer is going through and adding every single coin painstakingly. They might be adding the position for where these coins should show up, but they aren't going through and manually recreating each coin over and over and over and over again as individual obstacles. That would be incredibly tedious. Instead, what they do is they create one template, one coin template, one Goomba template, one obstacle template. And from there, these templates are used to uh, clone different instances of this object over and over and over again. You might notice over here, we only have one reference to hitting obstacles. We are only ever going to have one sprite called obstacles, but that condition actually works with anybody with the name obstacle, even if they're clones. So, let's get to it. Just for final words on the clone topic, you can think of a clone as being a copy with the same like genetic formula that makes up the object. In coding terms, this means it's going to have the same code inside of it as the original parent. So let's get to it. I want to show you guys how we create clones in this environment. So the first thing that we're going to do is we are going to hide the parent object, the obstacles. And once it's successfully hidden, what we're going to do here is time it out a little bit because we don't want to just start creating obstacles over here. We're going to time it out for as long as we can. Well, not really for as long as we can. If we did that, we'd be stuck here forever. What I mean by that is we're going to wait like 3 to 5 seconds. I feel like 4 is a good number here. Forever. We're going to wait 4 seconds. And then, at the very bottom here of control, there is the 3 basic clone commands. We can create a clone of ourselves or other objects. We have an event for when we start as a clone. And we have the ability to delete our own clones. This one's useful for cleanup, for when you want specific actions occur when you are a clone, and for creating the clones in the first place. So we're going to be creating clones of ourselves here. And this is all we need for this first section, actually. It's just going to be sitting here, waiting 4 seconds, pumping out a clone, wait 4 more seconds, pump out another clone, 4 more seconds, another clone, so on and so on, so on, forever. Fairly simple stuff. Alright. So there's only one goal for an obstacle. All it wants to do is start from the right hand side of the screen and go left. That's all it will do. The only change here is we're going to introduce a random number generator to decide what the appearance is of this obstacle to avoid it. So if you might remember, we have 3 different appearances. We have our tall mountain, we have a thundercloud, and I have my volcano. All 3 of these are sort of set up in a way so that way they will slide across, so that they can slide across at a specific height, regardless of which one I have. So there won't be any variances in actual height. The challenge comes from avoiding the actual differences, the physical differences of these obstacles. So for this one, you have to go really high. For this one, you're going to be forced to go low. This one, not so challenging. You can go somewhere just in this area over it. If you want to add more challenge, you can add different obstacles with all with varying heights. In my code section, we're going to have it start as a clone. And when it starts as a clone, we're going to make it go, the clone specifically, go as far right as possible. So this is going to be to, you guys remember, up, down, left and right. Going right is seen as increasing your x. So this should go as far right as we can. I'm going to set this to 300. And the y value should be about 0. We don't want to change its height at all. Once it gets over there, we want it to show up. Show. And then from there, we are going to have it move smoothly over to the left-hand side of the screen. This can be accomplished fairly simply with this block here. Glide 1 second to X and Y. What the purpose of this block is to actually allow you to basically fire and forget the moment or the actual travel of objects. It's going to sort of interpolate the actual position of our character as it moves. So I want it to be about 5 seconds before it hits us. And it's going to be going over to minus 300, 0 to do so. With this, we should have enough here to actually start seeing obstacles come towards us. Just gotta wait. There it is. See right now, there's not much variance here. I could probably be sending them further too. So I'm going to stop that. And you see when I stopped it, all the clones disappeared by themselves. They're not permanent copies, so when the game stops running, they'll delete themselves. The original will stay behind though. Let's see if you can't make it go a little bit further. Minus 400. Usually the bounds will allow you to go as far off as possible. There we go. That's way better. While still having a little bit of the sprite showing on screen. There's one last step that we're going to want here before we actually hit these obstacles. And that is under control. Under control. Specifically, we want to go to looks and switch costume to. Might be wondering how this can be used. It's actually fairly simple. If you go to costumes, if you look on the left, in very tiny text here, there's a number. There's 1, 2, and 3. Underneath the hood, these costumes are actually numbered. And we can access these individual costumes by putting in a number instead of the name. I'm just going to go ahead and relabel this there still. Volcano. Fairly simply, we can use this guy right here. Pick random 1 to 10. We can set this up to be 1 to 3 instead, and it's going to choose a random costume between numbers 1, 2, or 3. It's inclusive, so it's going to be any of those 3 numbers. If I do it now, see we've got our mountain. Gonna have to go high to avoid that. I hit it. You can see that we've got the game over section. We're getting pretty close, as you guys can see. We're gonna wrap this part up next. So when I start as a clone, we have this. It'll glide, and the last thing it has to do once it reaches the end, there's actually two things here it has to do. The second thing is actually deleting the clone, but we have one thing that we have to do beforehand, and that is to adjust our score by 1. Change score by 1. Easy. Just gotta go under. Basically, once it's done, it'll hit the end. It'll delete itself, and you can see my score going up as I pass over these obstacles. To make this harder, you can set it up so that way... Oh, there's an issue there. You set this up so that way these obstacles come at you a little bit faster. We're gonna finish that fairly quickly here. Let's just change this number lower. So this part right here, the number of seconds, actually is inverse to your speed. The more seconds you add here, the slower it will go. So if I want to make this go faster, let's say about twice as fast, we'd have to divide our current time in half. Now these obstacles will come at me twice as fast now. That's good pace. If I want to make it even harder, I turn down the time between when the obstacles show up on screen. So I could change this number over here, be like 2, and I should start seeing obstacles come at me at rapid pace now. Oof. If you want more variety, it's always good to add a couple more items in here. Or if you want to just have like the same 3 kinds, but maybe you want like the thunderclouds appear more often, you can just duplicate it. And in your code, you just have to make sure that you change that to the number of costumes there are. We're running out of time for today, so we'll wrap up next time. We've got a few more things to look at, such as making our characters disappear when the game's over, stopping our cloning system from keeping going on, the works. So the next video will probably be a little bit shorter, but we'll be allowing you guys to have a little bit of time to finish up your customizations. Something that I won't be showing you guys, but you'll need time to do if you want to add a couple more things. I'll see you guys next time.